Hi everyone, so in this video we're going to go ahead and talk about metals, nonmetals, and metalloids. So let's go ahead and get started. Okay, so some of these properties might be ones you already know about these different types of elements. So metals have luster, which means when you look at them, they are shiny. They also tend to be hard. They have a high density, meaning that the atoms are packed closely together. They have a high tensile strength, meaning they don't want to stretch. So if you take a piece of metal and you grab onto both ends, you won't be able to stretch it out. So those are some that we already know, but there's other properties too. So metals have high melting points and boiling points, usually a couple hundred to 1,000 degrees, so much higher than we're going to see. The only metal that's ever a liquid at room temperature is going to be mercury, and gallium's also a little special that it melts around body temperature. But otherwise, most metals have high melting points and boiling points. They're also really good conductors of heat and electricity. This is why we're going to go ahead and use those for things like wiring in our houses. And also when we cook food, we tend to use metal pots and pans because it helps the heat transfer from our oven or our stove to the food. Metals are also ductile, meaning they can be made into wires. So we know this because we have metal wiring in our house. We also use wires when we make jewelry oftentimes. And metals can also be malleable, meaning we can hammer them into very thin sheets. So we can see this with like aluminum foil, that we have thin sheets of that aluminum. We also have things like gold foil, which is very thin sheets of gold. So metals have all those properties. Metalloids are kind of the middle ground. So they have some properties of both metals and nonmetals, and they're a little unique in that category. Now for nonmetals, these are pretty much the exact opposite of the metals. So they are not shiny. They are soft because they tend to be either liquids or gases at room temperature. They have a low density, meaning the atoms are spread out, and they have low melting points and boiling points. This is why they tend to be liquids and gases at room temperature. Nonmetals, when they are solid, tend to be brittle, so we can't mold them, we can't shape them very well, they're going to break. And they're also poor conductors of heat and electricity. So they're not going to be good choices for things like pots and pans to cook food or for wiring and things like that in our house. So all of these elements tend to be grouped together on the periodic table. So metalloids are kind of in between the metals and the nonmetals, which should make sense because they share properties of both those categories. So the way we find the metalloids on the periodic table is we draw this imaginary staircase shown by that red line. That red squiggly line is the staircase. And this helps to separate the metalloids from everyone else. Now, one thing I do want to point out, aluminum touches this staircase, but it has more of the properties of a metal, which if you think about prior experience in your life, that should seem reasonable that aluminum is a metal. Otherwise, all the other elements that touch that red squiggly line, that staircase, are considered to be metalloids. The metals are everything that is to the left and below of that staircase. So the vast majority of the periodic table, those blue elements, are all considered to be metals. Now the nonmetals, these are everything that's to the right and above the staircase, so the top right corner, plus hydrogen. So hydrogen is a little bit of the oddball when it comes to periodic table organizations. Usually we see it on the very far left corner of the periodic table because it has one valence electron, and that first column of the periodic table has one valence electron. But it's really more like a nonmetal. So some people think it should really be put on the far right side of the periodic table. So that's something up for debate, but hydrogen is a nonmetal even though it's to the left of the staircase. Okay, so really quick phases of the elements. Most of the elements are solid at room temperature, which should make sense because, as we just spoke about, most of the elements are metals. Now, mercury and bromine are unique. They are the only two elements that are liquids at room temperature. Now, some of you might have heard about gallium, which is a very special metal. It melts slightly above room temperature at body temperature. So if you actually hold it in your hand, it will go ahead and melt. And there's a fun story about that called the disappearing spoon. So you can go ahead and check that out if you want more information. And then group 18, so the last column of the periodic table, the noble gases, plus the elements chlorine, fluorine, oxygen, nitrogen, and hydrogen. those are the gases at room temperature. Okay, so we have most of the elements are solids, 2 are liquids, and then the rest are gases. So thanks for watching, everyone. If you have any questions on this, please let me know. Otherwise, have a great day. Bye.